Okay guys, today we're talking about solving exponential equations. So that's our special guest, Mr. Palmer. So he might be asking some questions throughout. He was a little confused on this topic, so he came to our video session so he could learn also. So the goal is that both sides must have the same base to solve. So before you solve, you need to get them to have the same base. Sometimes they'll start out with the same base, but if they don't, you have to get them to the same base. Secondly, once they have the same base, all you have to do is set the exponents equal to each other and solve. So it's pretty easy once you get your goal accomplished. So example 1, we got 5 to the x equals 5 to the third. So I started off really easy for you. So you can see if it's 5 to the something equals 5 to the third, well then we know that the x must equal 3, right? So the bases are the same, you just set the exponents equal, and this one you didn't even have to solve. So let's try another one. Here, you see the bases are equal. So as long as your bases are already equal, the only thing you have to do is just set them equal to each other and solve. So go ahead and pause the video and solve this equation. All right, welcome back. So, of course, to solve this equation, I would add 2x to both sides. So I would be left with 3 equals x. And so that is my answer to the problem. Now, remember with equations, you can always plug it back in to check that you have the right answer. So just keep that in mind when you're solving, that is always a method to plug them back in, and that will help you to know you have the correct answer. Examples. So I told you that they won't always have the same base. So they'll always have some way to be put into the same base. If it's not possible to put them in the same base, that would be a question that would come up more in Algebra 2 because you would need logarithms to solve that. So that sounds like a scary word, so don't worry about that now. Okay, so we've got 3, 1 minus 2x equals 27. So we have to think, how can we get these to the same base? So we look at 27 and we see that that could be rewritten as 3 to the third. So 27 is the same as 3 to the third. So I just bring down my 3 raised to the 1 minus 2x equals 3 to the third. And now, like we said, if they have the same base, all I have to do is bring down the exponents and solve.
Ms. Perishow, I have a question.
Yes, Ms. Achilles.
When you change 27 to 3 to the third, is that because there was already a 3 on the left side for the base?
Yeah, since 3 was already on the left side, usually you're going to try to look at the numbers and see if you can turn 1 into the other. Now, I'm not going to turn 3 into 27. I want to turn 27 into 3. It's usually easier to make the bigger number into the smaller number.
Thanks, Ms. Perishow.
Okay, so now I have this, so you can go ahead and pause the video and solve this problem. All right, so welcome back. If I subtract 1, and then I bring down negative 2x equals 2, divide by negative 2, and I find out that x equals negative 1. Sometimes some of you forget when you're solving equations like this that you have to actually bring down that negative, so don't forget to do that. Okay, so the next problem, we've got 4 and we've got 16. So if we have 4 and 16, like I said, it's easier to turn the bigger number into a smaller number. So you can see here in pink, I did that for you, that I'm going to turn 16 into 4 squared. Notice I left the x up there because that x doesn't change. I'm just changing the base. And if it already has an exponent, I just keep that exponent outside of the parentheses. So now when I move down, I now have the bases equal, and I say 3x minus 5, and then I use the rule that when you have an exponent outside of the parentheses and inside of the parentheses, I just multiply them together. So now I have this simple equation, so pause the video and solve that equation. All right, welcome back. So I need to get the x's on one side. So I have negative x, and again I bring down this negative 5. So I can divide by negative 1, and I find out that x equals 5. Okay, so go ahead and pause the video, and I want you to try the last one on your own, and then when you come back, I will make sure you solved it correctly. Okay, so welcome back. Hopefully you looked at these, and you saw that 5 is going to be the common base. So I need to rewrite 125 in terms of 5. So hopefully you realize that that would be 5 to the third, and then I keep that x up there. And now I bring down the other side, which is 5, 2x plus 2. And so then I just bring down the exponents. So remember that I can use the power of a power rule to say that that's 3 times x. So I bring down the 3x, and then I bring down the 2x plus 1, and then I solve this equation. So I subtract 2x here, and I get that x equals 2. All right, I hope you have enjoyed our video, and we will see you next time.
Bye.